A-level maths, integration with trig identities. So in this question, we're asked to find the indefinite integral of 4 sine squared theta cos squared theta. So whenever you have these trig identity integral questions, if you can't see a clear path straight away, my advice is just write down all of the identities that you know and that you think are relevant, and see if you can manipulate this integrand into a form that is going to allow you to sort of integrate it, with in terms of elementary functions that you know how to integrate. So the relevant identity here is going to be the following. So we know that sine 2 theta is equal to 2 sine theta cos theta. Okay, that's just our sine double angle formulae. And the idea is, you can notice that, our integrand is precisely the square of this right-hand side. So if we square both sides of this identity, we get the following. Okay, so we have that, our integrand is actually equal to sine squared 2 theta. Now, this is still not sort of something we can directly integrate, but you should be aware at A-level maths how to integrate sine squared theta, okay? So sine squared theta, you should know that you need to use the cosine double angle formulae in order to integrate this. Now, we don't have sine squared theta, we have sine squared 2 theta, so we just have to be a little bit careful about that. But let's go ahead and write down, our relationship, that comes from the double angle formulae to sine squared. So we have sine squared theta is 1/2, okay, minus 1/2 cos 2 theta, okay? And if you don't know how to get this, right, start from, what they give you, which is, the compound angle formula for cosine, set A equal to B equal to X, use the plus, right? You'll get cosine squared minus sine squared, and then use, sine squared plus cos squared is 1, rearrange, sub in, right, and then rearrange to get this, okay? So practice doing that, don't have to remember it, you can just derive it pretty quickly. And the only difference here is that, we have, instead of theta, we have 2 theta, okay? So we could swap out our theta for 2 theta here, which tells us that sine squared 2 theta is 1/2 minus 1/2, and then, our theta's gone to 2 theta, so 2 times 2 theta is actually cosine of 4 theta, right? And sort of through this series of steps, we've shown that our integrand is actually equal to this expression on the right-hand side, and therefore we can just sort of rewrite this, okay? So therefore our integral is now the integral of 1/2 minus 1/2 cosine 4 theta d theta. And then all we have to do is, just integrate this term by term. So what do we get? Well, the half just integrates to 1/2 theta. And then this second term, right, so the minus cosine, if you like, is going to go to minus sine. And we have to divide by this coefficient here just to make sure it comes out, right? So we have minus 1/8 sine 4 theta. And then, plus c, because we always need our arbitrary integration constant when we're doing indefinite integrals. And always check, right, just to make sure you've done this part of the integration correctly. Just differentiate this term by term, right? So we get 1/2 minus, and then the 4 comes out, right? So we have our 1/2, and then the minus sine theta